Alright folks, just stick with me. Just a little bit more lecture and then we're going to get to some fun stuff. I promise. I know the stuff is dry, but I need to cover it anyways because this is the only opportunity to really cover it before we start jumping into it. This might get split up over two classes. I may just use this opportunity to lecture and then do my demo later, but we'll see how we feel about things when I actually get around to making them. And if we don't finish it in time this time, then I think we'll be fine. And then I'll just push the demo to next week. And I think we'll be okay, since I did give myself 2 weeks for this. Okay, so let's talk about variables. Variables live, and we're still in the level blueprint if you're curious as to where we are. Let me go ahead and close that, and we can reopen up the level blueprint so I can see what's going on. There we go. As you can see, this is based off of the previous demo where we just created a delay and I explained how all these nodes work and how to summon things and how events trigger, etc., etc. Let's keep going from there. So in short, variables are what blueprints use to store data. They live right here. Think of when you were in high school and you had to solve for x. That's one of the things that is a variable. It works the same way. So to create a variable in Unreal, the left side of the blueprint editor is going to be where you're going to spend a lot of time. Clicking the plus sign will allow you to create a variable and allow you, and by default, it's going to create a blueprint variable and it's going to showcase over here in the details panel. Now we need to get going to setting its data types so that we can figure out what it's actually going to do for us. And I'm going to go ahead and do this. Let's see, I'm going to take a screenshot here so that this can be persistent. So let's see here. Alright, there we go. And as you can see, we have different data types. Now, the data types determine what kind of data that it can hold. And one way of setting this data type is by clicking the data type that's living over here, or by selecting the variable and changing its variable type over here. I want to have this up so it's easier for me to kind of designate what's going on. The first one is a Boolean. So this is named after, I believe it was George Boole. All this does is it separates your data type into a true or false data type, either on or off, 0 or 1, off being 0, on being 1, true or false. And those are the only two values it can hold. So because of this, Boolean values tend to be incredibly cheap, and they take up incredibly small amounts of space and memory. I had to double check to make sure that it was actually George Boole, and it actually is George Boole who's dealt with the field of logic. Go figure that. So if you're ever asked who invented the Boolean, it's because George Boole dealt with programmatic logic. I'm going to talk about these other ones, although typically speaking we're going to use Boolean, we're going to use integer, float, we're going to use the name, string, and text, and sometimes use vector, rotator, and sometimes transform, and of course the other object types down here, which I'll talk about shortly. A byte, which is the second one here, let me see if I can zoom this in a little bit more so that people can see it. There we go. A byte is essentially a whole number, and not a floating point, a whole number between 0 and 255. That's it. So if you need to store between 0 and 255 values, this is probably the one that you want to use. Typically speaking, most people are going to use integers and floats. But if your code needs better performance and you know what you're doing, you're going to want to go ahead and use a byte. This is because it can store 256 values, including 0, and can store no more, because that's how memory addresses work in terms of programming. If you need more information on that, I would strongly ask your computer science friends, or I would spend a little bit of time understanding how computer science works. This is not technically a computer science class, but I am going to cover some of these concepts as we go. So if we need to store a variable of how many choices a player can make, and it's within 256 counting 0, because indexes start at 0, a byte might be a good data type. The next one is int, or rather an integer. So like a byte, an integer will still will store whole numbers, but bytes can only store between 0 and 255. If I'm remembering correctly, and I have to look at my notes here, you can store integer values between 0 and 2 billion, or excuse me, between negative 2 billion, sorry, and positive 2 billion. So obviously it uses more memory than a byte. An integer is probably the most usable type. It's the most useful and flexible type. And it's not that much more memory performant. An int64 we won't worry about, but that's like negative 9 quintillion, I think, plus or minus. Yeah, we will almost certainly never use this. We will almost certainly never use integer 64. Just know that it exists. I don't want to cross it out completely. Know that it exists, but I don't know what we'd want to use it for. If we're using int64 as blueprint programmers, we should probably be hiring someone who's an expert in C++. All right, a float. It's just a floating point number. 1.1 is a float. A number with any kind of floating point precision is just a number. It's just a name for a decimal point. So unlike integer, it can store values that aren't whole, like 24.7 or 3.5 or 69.420, whatever, right? And again, because it uses more precision with a floating point, it uses more memory than an integer data type. That's it. Or excuse me, than a yeah, it uses more memory than integer data type because we're able to have that floating point precision. We'll certainly almost never use a double, but this is basically just a floating point on steroids. It can hold much larger numbers than a float, but a floating point can hold basically everything that we need. I've never run into any issues with that, but a double is basically just a larger storage and a floating point. All right, so let's talk about these bad boys right here. Name, string, and text, and I'll talk about excuse me. I'll talk about what each of them do, why you want to use them, when to use them, and why you'd want to stay away from them from time to time. So, let's start with the text type. Here. We'll start with text. So the text data type is useful for displaying text, obviously, because it has things like localization. What is localization? Localization in Unreal Engine 4, and one of the tools and things that is commonly overlooked inside of Unreal, is Unreal has some fantastic translation and localization tools that are built into it. It allows you to basically translate and localize your game to certain regions or languages based on how you have written in English initially. So you can very easily convert a game to another language using the localization system for Unreal Engine. Both in Unreal Engine 4 and Unreal Engine 5 still have an incredibly robust system. However, only the text variable actually has access for those. This allows you to change things like text type. It allows you to change things from like maybe you're localizing a game for Russia and they use a Cyrillic language or they use special characters. It doesn't just translate, it does a really good job. You can put in a plugin that will translate, generally speaking, but it allows you to basically localize text to display in a way that is customized for a player's region or language. And with other tools, it can oftentimes do some simple translation for you if you have plugins that will help you do translations, although you should hire a localizer. That is probably a better idea than just trying to wing it. But a text variable has those tools available to it, and it is generally used for on-screen displays and on-screen text that the player can see. The next one is string. The string is used to store any amount of text that you can perform some kind of manipulation functions on. This includes, can I explain this? Um, extracting text from other text, um, reversing text like responding, uh, changing the elements of something in a variable, changing the elements of something in the naming convention of a variable, so on and so forth. Um, so if the text is not going to be displayed on screen and it's changing the code or changing the name of an item inherently or revaluing items, for those of you who've played a lot of games, you'll notice that items are sometimes stored as strings or items are stored as naming convention like broadsword underscore red underscore etc. And then of course modifying that changes it in the code but might not change its text name to the player. That's how we store certain weapons, for example, and how we modify certain weapons. This string is better for stuff that is not going to be on screen. All right? So if you might need to perform functions on the text and the text isn't going to be displayed on screen, you would store that in a string variable. All right? Let's talk about name now. I don't know why it bounces around whenever I click on it. The name data type doesn't have any of the other tools. It doesn't have localization or the other features of the text data type. Name is typically used for anything that doesn't need to be modified either permanently or otherwise and doesn't need to display on screen. That's it. If something has a name that is going to remain consistent throughout the development of the game and doesn't get modified or doesn't change and doesn't actually show up on screen, you would want to use this as a naming convention. So if you have a very specific item, like for example, if a grenade type is called grenade type 1, grenade type 2, grenade type 3, it might have a different text name on screen. But if we're referencing it inside of the engine as a certain name, and that name can't be modified or doesn't change throughout the course of the game, it's actually a little safer to use name versus string, because string implies that you're going to make changes or either increment or decrement, or modify or change the order of any names inside of the engine. So a string allows you to do all of those changes, and name doesn't allow you to change anything, but still allows you to save a name. You wouldn't want to use text for everything because text is the most expensive, and because it has the localization parameters, text is not going to be what you want to use when you are, trying to denote things like variable names, or if you're just trying to modify basic strings so you keep track of a weapon type and family or like its upgrades. You'll want to use name or string, but not text. Using text for everything other than stuff that's going to be on screen is probably going to be a mistake. Alright, we're almost done here, folks. Now that we're past this, let's go ahead and change our color here so that we can... There we go. Let's talk about vectors. So, vectors will store basically a float 3, or a constant 3. You guys remember a constant 3? That's what a vector is. This is useful for defining a point in space, an RGB value, anything that's defined with 3 values. That's all it does. Next is a rotator. This one's pretty simple. It stores numbers to describe an object's rotation in 3D space. That's it. And transform is what describes an object's position and rotation. So a rotator is a little bit different in the sense that it stores its rotation and its rotation in the 3D world space, whereas transform will describe the object's position, rotation, and scale in the 3D space relative to itself, right? I know that might seem a little bit confusing, but a rotator is typically used if you're going to store the numbers that describe an object's rotation, and this will store all of that and more. But oftentimes, if you only need to store rotation, you only store rotation, right? If you need to store things like rotation and position, and various other types of transformations, scale for example, you would store them in here. But if you only need to store position or rotation, it's probably a little easier to store each of these separately. And in fact, I tend to use vector or rotator more than I use transform as a whole, unless I'm doing any kind of scaling. So let's go ahead and close this for now. I've already talked about this. And let's go ahead and go back to our code here. And we're going to actually make a quick variable that allows us to change what is happening in this particular area of our duration. So remember we set this to 3.0, and after 3 seconds our game will quit. Let's go ahead, and I'm going to go ahead and delete that variable just for funsies, and we're going to make a new one. Left click the plus button under variable, and we're going to call this delay duration. Now, before I move on, let me be abundantly clear about this. You can write your variables like this. Where when it is written out, let's go ahead and actually change this value to a float. That way we have a little more precision, because this is looking for a floating point. Because if we have it a different data type, it will not be compatible. It will throw an error. So let's go ahead and change this to a float. Now it's asking us to compile the blueprint before we do anything else. Make sure you're reading these, and then compile the blueprint, it'll be fine. So let me be explicit about this. You can write a variable like this with the word delay, capitalize the word delay, capitalize the word duration, and it will show up on the graph. If I drag that out and I set it to a get, you'll see that we have a natural space between delay and duration. We can also write the same thing like this: delay, space bar, duration, and it will do the exact same thing. Those two variables are the same. What is not the same is delay underscore duration. This is a different nomenclature. It's going to be important from now into forever, by the time you're with me and by the time you leave from me, that you understand how you prefer to write variables. I tend to prefer writing variables with the supposition that I am going to write them like this. I write my variables as one word with an uppercase, and then the engine is going to automatically place my space whenever I need it. All right? That's what you need to understand when you're writing your variables. I would say take a moment now to figure out how you wish to write your variables, and write them this way forever. The reason why it becomes kind of problematic is if you start mixing variable types or variable nomenclature, or rather variable syntax, and it can be very, very easy to misconstrue one with another if you can't read what's going on. It's going to be a little bit easier to understand once you actually run into an error, but I like to avoid that error by telling students, hey, look, however you want to write your variables, you write them however you like. Make your dreams come true. However, you should write your variables all the same way, consistently, all the way across the board. The more comfortable you are with writing a variable type the way that you want to write it, the easier it's going to be to troubleshoot any kind of variable problems when they pop up. Okay? So I'm going to go ahead and change some values here. So if we put a hard value in here, and I'm going to go ahead and left click drag this out, and I'm going to set it to a get. And I'll talk about getting and setting here in a second. And I set this value to 3 seconds, and then I plug this in. This is functionally the same thing as what we had prior. When we compile and play, let's see if I can compile, save, and then actually play it, the viewport. 1 1000, 2 1000, 3 1000. Oh, it's kicking us out immediately. So we've got we've got our delay duration here, and oh, I forgot to hard code it here. So what we've done here is we have forgotten. I forgot to element this. This value is hard coded at 0. Let's go ahead and hard code it at 3. We'll compile, save. Now let's see what it's doing here. There we go. Sorry about that. Made a little mistake there. It should be kicking us out. There we go. 1 1000, 2 1000, 3 1000. There we go. So this is functionally the same thing. I forgot to write my 3 and hit enter. Make sure that when you change variables that you hit enter. I failed to hit enter, or I might have fat fingered a 0 in there and it gave me the wrong value. If we look over here in our variable storage, our variable is listed as having a delay duration of 3 seconds. Even if we change nodes and go back to our variable, our delay duration is still set at 3 seconds. However, we can override this function whenever we see fit. I'm going to go ahead and set this variable delay duration to 10 seconds, just to give an example. I'm going to compile and save, and we'll hit play. Now you'll see that it's counting down from 10 seconds. I'm not going to let that count down all the way. This is going to be the explanation on the difference between getters and setters. I'm going to go ahead, and even though this is hard-coded at 10 seconds, I'm going to drag our delay duration out here, and I'm going to grab as a set node. And I'm going to set the delay duration for 2 seconds. Now, as we can see, we also have the ability to plug in another variable over here. So we can continue to plug in variable on top of variable on top of variable. What a set node does is it sets the value of a variable as long as it's set into a layer of the execution that is going to execute before we actually get to our variable. Let's go ahead and plug in our set node here like this and like this. And we'll compile. Now what's going to happen is our setter here is going to set our delay duration variable, despite the fact that this is hard-coded at 10 seconds, to 2. Let's go ahead and play and simulate this. 1 1000, 2 1000. Boom. As you saw, this is working. But how does that work, Mr. Figueroa? This is supposed to be set for 10 seconds. It is. It is supposed to be set for 10 seconds. In fact, our variable lists this as showing 10 seconds. So what's happening? What is happening in the flow of execution is, on event begin play, we are setting our delay duration to 2 seconds, regardless of what is hard-coded into the variable, which at this point is 10 seconds. And then this delay is going to fire off whatever this duration is supposed to be, which is 2 seconds. And then we're going to quit the game. Let's talk about some of the variable parameters here. Instance editable we talked about already, because it sets it whether or not the instance is going to be publicly editable in the details panel in the viewport. Because this is a level blueprint, this does not show up in the level as an identifiable icon, and this one will not work. Blueprint read or only is going to make it so whether or not this variable is set by blueprint node or if it's read only. Let's go ahead and click that and compile, and we're going to get an error. Let's go ahead and read that error. And I'm going to go ahead and make this a little bit smaller here. There we go. SKEL BP demo map C, okay, whatever, is not blueprint writable. So what it's showing us is that this is our exit node. We are having an error. It is not compiling because there's something preventing us from writing to the actual variable. In this particular case, what I did was I hate this menu sometimes. It's like you make room and then it takes it away. We set the blueprint to read-only mode, and the blueprint read-only does not allow us to change the variable even if we're setting it. So if we uncheck that and then we compile, we can see that we are able to, again, set our delay duration based on what we want. Tooltips are useful because tooltips are like comments. Set delay until the game quits. And can be useful in the details panel, and do show up in the details panel if this was publicly visible. Do I want to talk about the other elements here? I do. I'll talk about these here shortly. Expose on spawn, and I'm going to skip private for now, and expose to cinematics are pretty complex topics, but essentially what happens is blueprints can be locked until they are exposed or used, meaning if they need to be protected or have their data protected until they actually show up, because we're manipulating so much data that maybe it's not being set properly until it's supposed to spawn later. That's kind of what's going to be useful. Exposed to cinematics is going to be whether or not the sequencer, the movie-making element inside of the engine, can actually modify the blueprint. Those two are kind of more complex, and we won't cover them in this particular session, but just know that they exist. Private is going to be a little bit different than blueprint read only. So private determines if other blueprints can access this variable. Blueprint read only decides whether or not that the blueprint that this variable is in can modify it, and blueprint and private decides whether or not other blueprints can reference this particular variable and then change it. Category allows you to make custom categories for your particular variables. So if you add a bunch of variables and say a bunch of these variables are going to edit a character damage or going to edit a character movement, you can go ahead and modify these categories, and then once these categories are set, you can use the drop-down menu to change their categories. Slider range and value range work really well if you are having blueprints that show up in the details panel that have a sliding range. It shows the range of the slider, but the sliding range doesn't mean how many values are in there. You guys have seen me put in numbers that were beyond what the slider would show. Especially during the lighting demo, if you remember. For example, I think the candle power taps out at 150 or 300. I can't remember which it is. But you can put like a 10,000 in there, right? Slider range is generally what the general acceptable range is to use a little sliding tool. Value range is hard-coded as to what values will actually go in there and what values will actually fit in the range. A slider is sometimes more useful if it's in a narrower range, where a value range is more useful if you can go beyond the range of the slider. Replication is for networking. And I'm not going to talk about any of these elements in here because these elements are a lot more complicated when dealing with how the blueprint is going to run. I'm going to keep those closed for now and not worry about that. And down here under default value, we have the ability to see what our default value is supposed to be. All right. So we've talked about variables, and that pretty much covers our variable discussion for now.